Okay, we're going to look at scatter plots today. So if you look, here's your basic scatter plots up here. You have a strong negative, meaning if you kind of put in a line of best fit, that should sound familiar, line of best fit. That should look like it's going through most of your points. That's a strong negative correlation because as x increases, your y is decreasing. So example, the more I exercise, what's going to happen to my weight? It's going to go down. That would be a negative correlation. A positive correlation, your line's going to go up. So if I kind of sketched in my line of best fit, it's going up. A good positive correlation would be the more I study, the better my quiz is going to be. That would be a positive correlation. So when you graph points, if they're kind of scattered and going down, that's negative. If they're kind of scattered but going up, that's positive. So we're going to look at these two, and we're going to graph the points and decide is it negative or a positive correlation, or maybe none. None correlation would be you just have points flying everywhere and you cannot see that it's going up or down. So let's graph this first one. So to graph, I have to go, my domain is going 0 to 8, so I can just count by ones there. And my range is going from 0 to 11, so I can probably count by ones there. And then you graph those points. So 0, 11, 2, 8, 7, 2, 8, 0. And once you have them graphed, you can kind of see what kind of correlation is that making. Yeah, I would say a negative correlation. Pretty strong, right? And if you take statistics with me next semester or next year, I'll teach you how to compute how strong or weak a correlation it is. There's a formula for that. If you look at this one, the next example, number of hours would be my x, my domain. That's my input. So what's the output? Would be my score. Number of hours I studied means this percent of score that I get. And if you look at your domain, I have to go from 2 to 11. So you have to count by 2s to fit it all. Actually, it's more, isn't it? Aren't I hiding some of it? Yeah, 14, there we go. So to go 2 to 14, you probably have to count by 2s. And my y's, I'm going all the way to 95. So on my y's, I'd have to count by 10s. And then I can plot my points. So sometimes you have to change your x and y to make it fit. So 8, 75, 5, 62, 12, 80, 1085, 235, 970, 1182, and 1495. So what kind of correlation did we get here? Positive. And that should make sense. The more hours I put in studying, the better quiz or test grade I'm going to get. Okay, so next, once I kind of know correlation, I can use my graphing calculator and find linear regression models. Right, so here's a bunch of data, and it represents linear functions. That's a given to you. You can find a linear model, something like mx plus b, right? M's the slope, b's the y-intercept, and use that model to predict things like this is the year, 2000, 2007, my data that I collected, and this is metric tons of pork production by China. Okay, so I can then use this linear model to predict in 2025 how many tons of pork is going to be produced. Or the other way, what year will 100,000 tons of pork be produced? Okay, and your calculator will do this for you. So you need to get out your graphing calculator. Okay. First thing you need to do is turn it on, and I need you to reset this because we've been using it all day. So if you remember how to reset, you go second plus sign, go down to number 7, all RAM, number 1, number 2, reset. And it should say RAM cleared.
Someone wrapped it around this tablet.
I know, mine almost fell.
Okay. So how do you put these in? You first need to decide what is my input, what's my output. Is the year the input or output, the X or Y? Okay, so what's going to be my input, my X, my domain? The years, yep. Year is going to be X, the inputs. That means production is my Y's, my outputs. You first need to decide that on each problem. Then you're going to put in these input outputs. You go stat, and then you're going to push enter on edit, and you have these lists. In list 1, you're going to put the years. List 2, you're going to put the production. Now, to make it easier, you could put in the years 2000, 2001, 2002, and so on, but easier would be 0, 1, 2, 3, 4. Okay, so you pick which one you want to do. I'm going to do 0, 1, 2, 3, 4, 5, 6, 7. And then your list 2 is going to be your production. So 40, 42, 43, 45, 50. Everyone got them?
Nope.
You don't have to put a comma. You could have put the years if you wanted 2000, 2001. That's okay. It's just your linear equation is going to be different than mine. Everyone got it? Okay, once you have list 1, list 2, okay, you're going to calculate a line of best fit. So you go stat, you have to go right arrow over to calc, and then you're going to go down to number 4, see it says linreg, and you have this mx plus b looking thing. They use A, we use M. You go down to number 4, you push enter, and then you push enter again. And it'll give you your linear equation. This is your A, your slope, you put that in for A. This is B, your y-intercept, you put that in for B. So your linear equation looks like this. Y equals, so now if I go stat, calculate, whoops, linreg, all right, that looks better then, right? So I have y equals, did you guys get that? 6, 7. There we go. That's better. So now I can put 25 in for x. Okay. And that'll be how many tons? So what's that equal? So 20, 53 times 25 plus, I'll edit it. So I still put 25 in for x, and then I get 91087.92. So regardless if your equation is different than mine, you should still get 91,000 metric tons. Good. Wow. All right, part C.
I think you're losing your touch.
It says use your linear model to predict when production is likely to reach 100,000 tons. So is 100,000 going for X or Y? Y, because tons is my output, the Y. So I'm going to switch this around and put 100,000 equals this equation, and I got to solve for X. So how do I solve for X? I'm going to subtract the 39,000 and then divide by the 2,000. Right? Get X by itself. So solve for X. So 100,000 minus 39,758.67 divided by 2,053.17. Okay, and what you get is 29.3. So you'd have to say in the year 2030 that I'm going to reach that, because this is saying 29 years plus another third of a year. So you can't say 2029 because it doesn't happen until into the third of the next year. So it'd be 2030 that I would reach 100,000. You always have to round up to the next year. When will it reach that?
John, that is a lot of work.
So this example is saying the table shows relationship between calories and fat. So before I put this in, stat, edit, I need to decide which is going to be my input, which is going to be my output. Which is my domain, which is my range. On this one, it doesn't matter. Let's just have calories be X, grams of fat be Y. You can actually switch those around on this problem. Your equation will be different if you do, but I'm going to let calories be X, fat be Y. So here's a quick way to clear your list so you don't have to delete all the numbers. You go up and highlight the L2, push clear, and then your down arrow, and it clears out the whole list. Or, right again, so I go up to the L1, push clear, go down, it clears out the whole list. So then I can put the calories into my list 1. Fat grams in list 2. Which one did I forget? 46, 30, 27, 26, 13, Okay, so once you have all your numbers in, you go stat, calculate, number 4, enter, and you should get that, right? So So I have this equation, y equals 0.07x minus 9.27. And my question is, how much fat would you expect a 330 calorie hamburger to have? Would 330 go in for my x or y? What is calories? Calories is x. So I'm going to put 330 in for the x and solve, and that'll give me how many grams? So 0.07 times 330 minus 9.27. So I should have 13.83 grams. That would be my answer.